One of the things we all do is we have to deal with neutral CAD geometry. So I'm going to go ahead and open up a step file. And if you notice here, there is a .stp and a .step. So I downloaded a screw from McMaster-Carr. I'm going to bring it in. Let this open up. And I see my part. And it's got threads on it, and I see half cylindrical faces here. So in NX, when it resolves other CAD geometry, it turns it into half cylindrical faces on both sides. So on my Home tab here, I'm going to come over to my Synchronous Modeling toolbar. I'm going to come down to Optimize Face. Optimize Face, when I select all body faces here, it's going to tell me that it's going to remove parameters from the part if I have parameters in the part. This one doesn't have any in it, so it's probably not going to ask me anything. But what it's going to do is then remove those half cylindrical faces. And then the number of entities that it has resolved has gone from 327 down to 214. If you look at CAD as a tool, the hidden line rendering is something that takes a lot of processing power. So all these threads that are on the backside are causing a lot of processing power. So if I have a lot of these screws in my assembly, then it's going to just hit my video card and slow things down and make my performance a little bit slower. So I'm going to clean this up a little bit more. I'm going to use a delete face and delete that top chamfer off there. I really don't find that to be all that useful. And then sometimes on these, I know things are going to fail, so I'm going to go ahead and pick the root, and it goes to a sharp. As soon as I pick one of these threaded faces, things start to fail, and I know that's going to fail. I'm not done picking everything yet, so I'm just going to go ahead and uncheck my preview and go through and pick some of the ones that I know that I need to pick up in this part. Then at the end, I can say show result, and there you go. Just say, okay, now I have a smooth shaft. I want to make this part a little bit smarter. I see that I have a chamfer on the end here, and I want to put what's called a linear dimension. So I'm going to create a relation to my part. Okay, this part is 50 millimeters long, and if I were to key in that I want it to be 60 millimeters long, I see a mistake. I missed something here. It's missing that chamfer on the end. So I'll come back to my faces to move, and I'll pick up that chamfer, and now I can move that 60, 75, show result, and I'll key it back to 50 where I'm starting and say, okay, what can I do with this information now? Well, I can go to my Tools tab right there and turn this into a part family. So very, very easily, I have to find out what my P value is. It's P10. I could rename that to something more logical, but I'll go in and make a part family, take P10, add it to the list below. Then from here, I can create a part family out of a relatively dumb part. So I could key in that I wanted to be at 55, 60, 65, and then, part number 1, 2, 3, 4, 5, 6. I'll copy all of these over. And then if I select one of these lines, I'll go down to my add-ins and I'll verify the part. I'll apply the values or verify the part. And I can see that it's updating properly. Resume spreadsheet. Try one of my longer ones. Maybe I'll make this one 100 millimeters long. And verify that part. I see that it's applied properly. And I can build a spreadsheet up from this. So from here I can just say family, escape out of the spreadsheet. And my family has been created. And I can then use this for assembly work.